Given an array of integers with even length, design an algorithm to check whether this array can be reordered such that into pairs, one number in the pair is exactly twice the other number. That's about today's video. Let's dive in. San Francisco Bay Area, or Silicon Valley. This is where my dream started. Hi everyone, this is Steve here. Today we are going through LeetCode problem 954, array of doubled pairs here. Let's take a look at the problem first. Given an array of integers a with even length, so it's either 2 or 4 or 6 or 8, return true if and only if it is possible to reorder it such that a 2 times I is the index, plus 1 equals to 2 times a 2 times I for every single I that is greater than or equal to 0 or less than half of the array length. Let's just take one example, 3136. The output is false. Let's take a positive case to go through so that we can have a better understanding of what that actually means. Okay, let's take a look at this one. 4 minus 2, 2 and 4. We can take two, the output is true. This is the only positive case. Output is true. We can take two groups. The explanation goes like this. Two groups, minus 2, minus 4, and 2, 4 to form either this array or this array so that it meets this requirement. Let's take a look what that actually means. This one, so here we'll say I equals to 0, right? Okay, I equals to 0. So this becomes I equals to 0, so this is 0 plus 1, so a1. a1 equals to, this is a0. 2 times 0 is 0, so a0. a0 is here, a0 is minus 2, so minus 2 times 2 is minus 4. And this one is 0 plus 1 is 1, so a1 is here, a1 is minus 4. So minus 4 equals to 2 times minus 2, which equals 4. That's why these two elements in this group meets this definition, meets this requirement, right? Okay, we just finished going through this pair, and now since here I equals to 0, so we just finished I equals to 0. Then let's increment I by 1. I becomes 1 at this point. Then we have here I becomes 1, which is, let's just use this one as the final example, as the final result to reorder this array. So I becomes 1 at this point. Then we'll take I equals to 1 here. 2 times 1 plus 1 is 3. 2 plus 1 is 3. So A3 is here. 0, 1, 2, 3. A3, index 3 is 4, right? And then we'll take I equals to 1 again into this formula. 2 times 1 is 2, so A2. A2, 0, 1, 2. A2 is here, is 2. So 2 plus 2 is 4. So 4, 2 times 2 is 4, and 4 equals to 4, right? This is why this is one valid result that we can return. The same is also true for this. When we go through I equals to 0 and I equals to 1, we can have this one, 2 times 2 equals to 4. And minus 2 times 2 equals to minus 4, which also equals to minus 4 here. That's why the explanation goes like this, and given this input, the output returned is true. That's the explanation of the positive cases. We're given three negative cases. For example, here, 3136. There's no way that we can reorder this array such that, like say, it could be any pair. We can reorder such an array for the outcome such that it can be grouped into a pair of numbers. One number of the pair is exactly twice the other number. There's no such a possibility. Say this one can be grouped into one pair. 3 times 2 equals to 6, but 1 times 2 is not equal to 3, so it's false. So does this one, and so does this one. That's the There are some notes here. 8 is always even, and it defines the upper and lower boundaries of the given array. That's it. How can we tackle this problem? There are multiple ways. The way that I think of is pretty straightforward, is that of course there's going to be negative cases. The way that I think of it is that we can first sort this array, but of course we want to change. One easy way to handle the negative numbers is that we can turn all of the negative numbers into positive numbers. This is one easy way to handle it, but of course in real interviews, if you do this, just to clarify this with your interviewer first, because it's not always recommended to change the input. So usually in Java or C++, it's when the parameter that takes in is usually final. So which means it's not recommended, it's not best practice to modify the original input. But for the simplicity of this problem, we can do it. What we can do is we can change all of the negative numbers into positive numbers to simplify the problem and sort this array. And then next step that comes into mind should be we can use a hash map, because we can use a hash map, the key of the hash map. Okay, let's just put it this way. Draw some notes to help better understand. Okay, the output is 4 minus 2. The input is 2 and minus 4. This is the original input. What we can do is that we can first step, let's just turn all of them. Let's turn all of them into non-negative integers so that we can easily sort them and construct a hash map. We'll go through that one by one. So first, turn all of them into non-negative, like this. And then next step, we're going to sort it. And then next step is we can build a hash map. The key is going to be the number itself, and value is going to be the count, which is 2 here. So in this hash map, it's going to be looking like there's going to be 2 entries here. It's going to be 2 maps to 2 and 4 maps to 2. So what that means is that the key is going to be the number of distinct values in this given array after we turn them into non-negative integers. And the value of the hash map is going to be how many times that the same number appears in this transformed array. Why do we build this hash map? Now let's talk about this. When we build this hash map, what we can do is that we can traverse this array the second time. We can traverse this array again once, but the second time when we traverse this array, we'll just check, say, this is the first time we traverse this array. We check whether this, do we have a corresponding double number in this map, in this hash map. Okay, so first thing that we're going to check when the second time we go through this transformed array is that first check, say, we built this hash map already, and then we go through this array again. So first we come into 2. We check whether 2 does, whether we have gone through this already. If we have gone through this 2, we will mark the account value to be 0. That means we have gone through it. We don't need to go through this again. But say in this case, this is the very first time. So we'll just, this is the count of the number 2 is not 0 yet, so it's 2. What we can do is that we can just double this number. 2 times 2 equals to 4. The second thing we want to do is we want to check whether this map contains a key that has a value equals to the twice of this number, right? Which is 4 in this case. And then the third step, what we want to do is to check whether 4 contains at least the same amount of frequency that this number appears in this array. In this case, it's 2, so it's perfectly fine. And if we can change it to 4, to 3, or 4, or to 5, that's totally fine. And after this, after we go through this, we will just decrement the double numbered frequency by 2, by this number, because we need the same number of double number to balance off this number so that they can be grouped into pairs. I hope that makes sense. In this case, there are 2 2s and 2 4s, so it's just a precisely balanced off, so we can return true in this case. But for other complex examples, we can just decrement the double numbers frequency by the number that the half number has appeared in this given array. And we'll just continue to do this. The second number we'll go through is 2, but at that moment, this one is already 0. So again, as I said, once we encounter 0, we're just going to continue in the for loop. So here, after going through the first 2, both value becomes 0. And then we encounter 4 again. So again, we check in the hash map, 4 is corresponding to a 0. So we'll just continue. The same case applies to this 4. We check in the hash map, 4 is mapping to a 0. So we'll just continue. After that, when we go through this entire, after we go through this entire array, if we didn't break out, that means every single number in this transformed array can be assigned, can be reordered into a double pair. That's what it means. But at any moment, say if we have another case, let's call it let's just use this example. This is an active example. Add a line here, insert, this is a positive, this is not 3136, let's call it here, 3136, 3, 1, so we're given 3136. So the hash map is going to be looking like 3 appears twice. Okay, we'll sort it first. 1, 3, 3, 6. We'll sort it first, and then 3 becomes 1 has appeared only once in this array, and 3 appears twice, and 6 appears only once. And at this moment, we have built this hash map. We'll just go through this sorted array again. So say 1, where we are encountering 1 once we go through the transformed array the second time. We check in the map whether 1, it's not equal to 0. It has appeared once, which has not balanced off yet. So we'll double this number, which equals to 2. We'll check in the hash map whether there's an entry with the key equals to 2. Unfortunately, in this case, there are only 2 other entries, which is 3 and 6. None of them equals to 2. So in this case, we'll just break out. Why? Because we're missing a 2 that could possibly make this 1 a double pair. Because we're missing a 2 here. That's why we can just return false directly from here. We'll just break out. That's the negative case. I hope that's all clear. If that's all clear, then we can start writing the code. Then we'll go through the time complexity and space complexity in the end. All right. Here, what we'll do, as I said, we'll just first we'll transform all of the just in case if there are any negative numbers, we just turn them into positive numbers. If again, this is not super recommended, but it simplifies the solution of this problem. You would like to talk to your interviewer first whether the original input could be modified. If it cannot, and if you still want to go with this route, you can just use a temp variable to assign the original input into the temp variable and do modification on the temp variable. If AI is smaller than 0, what we'll do is AI minus AI, turn all negative numbers into non-negative numbers, and then we'll sort it. Why we want to sort it? Because every single next biggest element we want to go through the smallest elements possible first. Let's see. We'll sort the array, and then we'll build a hash map. New hash map as I said, the key is going to be the distinct elements in this array, and the value is going to be the frequency of that element. So let's do this. Num a, oops, uppercase a, put map put num map get or default num 0 plus 1. Default is 0 and plus 1. That's it. And now we'll go through this array again. So first, there's one more possible case, which we can talk about, which is this case. Let me insert a horizontal line here. There's one more possible case. For example, it's this case and this case. So we're given like a bunch of zeros. So depending on, apparently we know this is going to return true, and this is going to return false. This is a special case when the input array consists of all zeros. So we know if it's an even number of zeros, it can be all balanced out. It can be 2 zeros, 4 zeros, 6 zeros, and we can always group any of the 2 zeros into one group, which is a double, because the 0 times 2 always equals to 0, right? But if there's given odd number of zeros, in this case, we'll just return false. This is a special case, we'll just handle that first. So say we get, let me actually put that in a variable called count, map get number. Say if number not equals to 0, we'll do a lot of things, but else if number is equal to 0, what we'll do is just to check if count is odd or even. If it doesn't equal to 0, that means it's this case. All of the number is 0, and we'll check the frequency of the zeros. If the 0 is not equal to, is not an even number, we'll just return false here. That's what this means. And after all of that, we'll just return true if it doesn't break out in any of these. Okay, so now we'll just handle the regular cases where num is not equal to 0. So looking at the notes here, where num is not equal to 0. So first, what we will do is we will check whether this one is greater than 0. Let's handle the negative cases first. If count is smaller than 0, what's that possible cases? When that one is smaller than 0, we'll just return false. Else, if count equals to 0, that's those cases, like say, after we go through the very first element, we decrement the frequency to be 0, and we decrement the double numbers frequency to decrement the frequency that the half number has. In this case, it becomes 0 as well. So if it becomes 0, after we go through the first element, we traverse to the second element. We found the second element's value is already 0. So in this case, which means we have gone through all of them, we'll just continue. Oops. Continue. Else is the positive case, which means, like say, for example, this is the first time we encountered this too. It has a value which is greater than 0. What we'll do is we'll use another number called double, as I just said, which is 2 times this number, none. Yeah, this number. First, we'll check, as I just described, we'll check this number times 2 is 4. Whether this hash map contains an entry that has a key equals to 4, right? This is what we're going to check. If map contains key double number, if it doesn't contain this number, we can just return false already, right? This is this case. 1 times 2 equals to 2, and this value is not equal to 0, so we cannot skip it. We'll just check if this map contains an entry that has a key with value 2. 2. No, it's not. There are only 2 entries, 3 and 6 here. So in this case, we can just break out. Otherwise, what we can do is we'll put this double, we'll decrement this double number's frequency by get double number minus count, which is this case, which is when we check there's 2 times 2 equals to 4, we'll decrement this double number's frequency by this count, which is 2 minus 2 equals to 0. That's it. And yeah, that's the algorithm. Let me double check. Oh, the other thing that we want to do is, as I just said, we'll do this when we first encounter this key, which has a value that is greater than 0. What we will do is we'll decrement that one to be 0, which means we're going to remove all of them. We're going to try to find this number's doubled number value pair. We'll decrement this one to be 0 first. Yeah, let's try. Let's run code and see if there's any compile error. I hope not. Okay, accepted false and false. Okay, that's good. All right, then let's submit and see. Cool, accepted. Yeah, it's kind of verbose and lengthy. It might not be super optimal. I see on Discussboard there's quite a few users have put up solutions that don't necessarily need to convert the negative numbers into non-negative, which is super awesome. I didn't take too much effort to read through all of them, but the basic idea is very similar to use a HashMap to count the frequency and try to find the pairs. Then let's talk about the time complexity. The most time-consuming part is to sort this array. It's n log n, and the space complexity is just O n O or OK. K is the distinct number of elements in this given array, because for every duplicate number, we'll just increment the frequency of this entry. That's it. I hope you guys like this video. If you do, please do me a favor and smash the like button, and don't forget to subscribe to my channel. I'll see you guys in the next video.